Alrighty, we are now back with question 7. This is a question on Bayes' theorem, except that you would get full marks if you just solve it using a tree diagram. So, we have two events, pregnant and test positive. %40 of the foxes are pregnant, so 60% not pregnant. If a fox is pregnant, test positive is 90%. If it is not pregnant, test positive is 20%. This is a terrible test. A. Find the probability that a randomly selected fox from the group would test positive. 0.4 times 0.9 plus 0.6 times 0.2. And this is 0.48. Part B. Find the probability that a randomly selected fox from the group is pregnant, given that it tested positive. So, we are asked to find P pregnant given positive. So this is P pregnant and positive divided by P positive. P positive, which is found to be 0.48. P pregnant and positive, that is the first term. So 3 by 4 is our final answer. Question 8, polynomials. We have real coefficients. This means that you can just look for conjugates. By considering the sum and the product of the roots of P of Z. Okay. So let's first look at the sum. If the roots are a minus y and 2 plus b, a minus I and 2 plus bi, the other roots would be a plus I and 2 minus bi. So that implies the sum of all the roots is going to be 1 by 3 plus 2a plus 2b. Plus 4. And this is equal to 7 divided by 3. So a is therefore 2a is going to be negative 2. A is negative 1. Second part. Find the value of b. We're also given the product. Okay. So minus 1 to the power of 5 times negative 26 divided by 3 is equal to the product of all of these numbers. Minus 1 minus I times minus 1 plus I. This is going to be minus 1 squared minus I squared. 2 plus bi times 2 minus bi. This is 2 squared plus b squared. And thus 4 plus b squared is equal to 13. B squared is equal to 9. B is plus or minus 3. We also know that b is greater than 1. B has to be equal to 3. Part B. Now we want to factorize P completely with real coefficients. Okay, so let's take the 1 by 3 first. This factor has to be 3x minus 1. The second factor comes from these two roots. For this to be true, it has to come from this polynomial. And likewise, for the last one, it has to come from this polynomial. So expand and simplify, and you're done with this question. Classic bark but no bite. Looks scary. It really isn't. 9. Okay, so this one is scary. Part A. We want to show that phi dot A is equal to 0. Sure. So V dot A is A dot C times B dot A. Minus A dot B times C dot A. Because it is a scalar product, you can move things around. So I'm going to move the A first, make it over here. And I'm going to move A and C. I'm going to swap the order of these two. These two are identical, so we get 0. This is a constant, this is a constant, this is a constant, this is a constant. We're good to go. Part B. It is given that B cross C and A cross B cross C are non-zero vectors. Okay. Justified by why B dot B cross C is equal to 0. Why is this the case? What is B cross C? B cross C gives you a vector that is perpendicular to both B and C. By definition, it is perpendicular to B, and therefore the dot product between these two has to be 0. Second part. Show that phi dot B cross C is also equal to 0. Okay, I'm going to substitute V in. Then I am going to split up. We just showed above that B dot B cross C is equal to 0. And similarly, C cross B cross C, C dot B cross C is also going to be 0 for the same reason. B cross C is perpendicular to C, so C dot B cross C has to be 0. Part C. Hence, okay, state the geometrical relationship between V and A cross B cross C. Okay, what do we have so far? We have V dot A is equal to 0. So V is perpendicular to A, right? V dot B cross C is equal to 0. So V is perpendicular to B cross C, right? What is A cross B cross C? What does it give you? It gives you, by definition, a vector that is perpendicular to both vector A and vector B cross C. In other words, these two are describing parallel vectors. So, if you will, let's say we have A is over here, B cross C is over there. Remember, B cross C is a vector. Crossing them, aka this guy, will get you vector, I don't know, N, for instance. We also know another vector that is perpendicular to both A and B cross C. So, say something over here, call it M. And the two vectors don't have to start here, right? It can start anywhere as long as it is perpendicular to the plane. And therefore, these two vectors are parallel. And this is the end of section A.